So, last time I had talked about Brahmagupta's verses on addition, subtraction and multiplication. What remains is division, and this would require a long discussion. So, these are the Brahmagupta's rules, and what I have done is that when it comes to when 0 is involved, those verses I have colored them, because negative is kind of routine, you can expect what the statements would be, but somewhat different from our convention is his statements on the 0. So, a positive divided by a positive becomes positive, and a negative divided by a negative becomes positive. So, this thing is there, but then he says kham kha bhaktam kham, bhakta is the division. So, 0 divided by 0 is 0. Then the next one is all right, positive divided by a negative, and a negative divided by a positive becomes negative. Then again, so this is the first paragraph, there is a statement that 0 divided by 0 is 0. And then again in the next verse, it starts by saying a positive or a negative divided by 0 becomes an entity having that as denominator. In other words, a divided by 0, where a is either positive or negative, you just keep at 0, that is, it is a new number a by 0. Likewise, 0 divided by negative or positive, square of a negative or a positive is positive, square of 0 is 0, the square root of a quantity is the one whose square it is. So, in symbols, what he is saying amounts to this, that plus a divided by plus b is plus a by b, minus a divided by minus b is plus a by b, 0 by 0 is 0, plus a by minus b is minus a by b, minus a divided by plus b is minus a by b, minus a whole square is plus a square, plus a whole square is also plus a square, and 0 square is 0. So, this combined with the rules which I had given in the last talk were quoted by Mumford, and then David Mumford says, so this is Mumford has an article on the history of negative numbers, not just about the history of India, but general. So, in that, and this article appears in the book Studies in History of Indian Mathematics, edited by C.S. Seshadri and published by Hindustan Book Agency. So, it has excellent articles by several scholars, and Mumford's article is on the history of negative numbers. So, there he devotes considerable space to Indian mathematics. So, what I am saying is Mumford was not focused on 0 in that article, he was on negative numbers. But in Brahmagupta, negative and 0, all these things positive, they come together, you cannot separate them. So, Mumford quotes the whole passage and then says, the only oddity seems to be his confident assertion that 0 by 0 is 0, the rest is as clear and modern as one could wish for. So, the rest is as clear and modern as one could wish for. Now, all historians of mathematics, I mean even the great ones like Vibhutibhushan Datta or R.C. Gupta, at this point they have called that Brahmagupta made an error in saying 0 by 0 is 0. But mind Mumford's word, Mumford does not say this is an error, he just says it is oddity, that is an something peculiar. He just calls it peculiar, he does not call it wrong. It does not of course match our our approach, but just leave that. He says that this is oddity, but if you leave that aside, the rest is as clear and modern as one could wish for. Now, so in our language, Brahmagupta has declared 0 divided by 0 equal to 0, and subsequently many other mathematicians have also said that. Bhaskaracharya avoids it. Bhaskaracharya does not talk about 0 divided by 0.
He said it 1 equal to 1, right?
Not Bhaskaracharya, that is somebody else. I mean this has come 0 divided by 0 is 1, and that comes between Brahmagupta and Bhaskaracharya, one of the I think probably Mahaviracharya, but I will check and say it is there in my paper. So this is there, 0 by 0 is 1 has been mentioned by somebody, but that is not Bhaskaracharya. Bhaskaracharya has not talked about 0 divided by 0. But both Brahmagupta and Bhaskaracharya have defined new numbers a by 0, where a is non-zero. So,
divided by 0 seems to me clearly limit of sine theta over theta.
no, see, there are one can take several approaches there. So, this Brahmagupta and Bhaskaracharya both have talked about non-zero divided, non-zero divided by 0 as new numbers. Brahmagupta called that kha cheda. Kha is 0 and cheda is division, 0 divided number, and Bhaskara calls it kha hara. Hara and cheda mean the same thing. And the point is that Brahmagupta just defines that, leaves it at that. There is no follow up. And Bhaskaracharya does lot of work with that, defines operations with this kha hara, that means a by 0 where a not equal to 0. Bhaskaracharya does lot of work. So, this is this is a theme for a talk of 1.5 hours, but that would be mostly on Bhaskaracharya, but since our series is on Brahmagupta, so I won't talk in that details, but still it will be quite long, longer than 30 minutes today. And
since they are also motivated by astronomy.
No, that is not the whole.
0 over 0 is like yard divided by the angle.
See, that is that is because you are always reading astronomy into verses which are not meant to be that. So, Bhaskaracharya has two approaches. One in his Lilavati, which fits the astronomy, and in Bij Ganit it is pure algebra, because he gives idempotent property, which will not be satisfied by the epsilon of astronomy. So, this approach is something radically different. It is pure algebraic, these are pure algebraic objects. Brahmagupta also, I will come to that these have to be viewed differently. So, just before coming to some technicalities, so ancient Indian algebraists not only embrace 0 as a number and allow it to participate in the ring theoretic operations, and in that they are the pioneers, but they go beyond what we permit now. They have also included 0 as a divisor in division. As division by 0 is strictly forbidden in the present edifice of mathematics, references to numbers with 0 in the denominator shock the modern reader. So, what do writers do? So, there are 4 kinds of writers. So, admiring modern writers sometimes tend to gloss over statements by ancient Indian mathematicians on division by 0. So, for example, Bhaskaracharya's Bij Ganita, there are some examples which if you interpret in the language of calculus, then they just do not make any sense, calculus or astronomy. And so, what happens is that some authors omit the statement, just quietly leave that aside. And the more objective authors like Vibhushan Dutta or R.C. Gupta, they frankly call them errors in otherwise remarkable texts. Some mathematicians, they charitably remind us that our mature understanding of the issue has evolved over a long period of time, over several centuries, that now we know division by 0 is not possible, but you should view them compassionately, because the ancient greats did not have the benefit of hindsight that we have. So, this charitable attitude is taken by some of our mathematicians, And of course, authors on the lookout for opportunities to debunk ancient Indian mathematicians, they welcome this as very handy ammunitions. So, one of them, Robert Kaplan, has this book, Nothing That Is. Just see, I mean, he has just no idea whom he is talking about, because after all, we ourselves have not given Brahmagupta the recognition he deserves. So, the very arrogant style, he calls Brahmagupta's rule 0 by 0 as just out and out wrong, and then adds, if you really could divide by 0, then all numbers would be the same, and then he gives this argument. Why? Our Indian math, so he sarcastically refers to the Indian mathematicians, help us here, any number times 0 is 0, that you have seen. So, he says, so 6 into 0 is 0 and 17 into 0 is 0, hence 6 into 0 equal to 17 into 0. If you could divide by 0, you would get 6 into 0 by 0 equal to 7 into 0 by 0. The zeros would cancel out and 6 would equal 17. So, this is a nonsense argument he is giving. So, they are not equal, so you can't legitimately divide by 0, a by 0 does not mean anything. And then now they go on to philosophy of why the Indians made this error, and this will be lapped up by, I mean, there are people who are on the lookout for this kind of statements. So, this sort of proof by contradiction was known since ancient Greece. Why hadn't anyone in India hit on it at this moment when it was needed? Surely in part because proofs like works of art come not at our bidding, but through the still unfathomed workings of insight. So, the insinuation is that the Indians like Brahmagupta or Bhaskaracharya did not have the insight, okay. But it does not stop there, partly because the style of Indian mathematicians was to assert principles rather than prove them. So, this is the next howler, and partly it may be because to say something is meaningless is almost like saying you do not know what it means. So, therefore, Indians could not say that this is meaningless, because then people will think that that they do not know the meaning. So, first of all they do not have insight, then they are just assertive, they do not know how to prove things, and even that is not enough. Then next is that they were conceited. So, so much is generated out of that 0 by 0 is 0. So, then Kaplan tries to establish that as Indians hated to admit their ignorance, they could not declare a concept as meaningless, as it may give the impression that they do not know it. Now, once Kaplan has written it in a book, then it generates. So, this series is actually quite useful, this Conner and Robertson MacTutor articles. But in their article on history of 0, they basically make similar points, of course, influenced by Kaplan, because you can see the year of publication. And of course, they do it in a sober style, not in this derogatory way, but as far as the content is concerned, they say roughly the same thing. And then that in India there are people. So, what happened is that in April and October, in April 2002, I started writing a series on mathematics in India. So, they were published in April, and then next one was in October, and that created kind of alarm bells. Why suddenly maths in India is being written? So, somebody from ISI, an institute of national importance, but not in our center, so he immediately rushed one article which was published in January 2003. So, it was actually, meaning I am the culprit, because I wrote on maths in ancient India. So, somebody had to write and wrote all these things about that Indians, I mean whatever I was saying. So, basically the things were cut pasted from this Conner and Robertson article, and that bibliography does not mention that, of course, but you can see, compare that and this person's article. and this is very sad. I mean, incomplete understanding, and that is copied by reputed professor from a reputed institute. So of course, I am mentioning the name because when I was writing my article, I had not mentioned the name, but then people pointed out then it does not look authentic. So, you should give the precise reference. And once I remembered that in some conference I was informally mentioning about this, and what happened is that this article was so bad that people thought that there is some problem between, I mean, because I wrote it, people could not even believe that it was a reaction to the fact that an article is being written on ancient Indian maths. There was nothing personal, but it got such a thing that when I was alluding to this, Divakaran knew whom I was talking about, and he told me, look, if you have any problem in ISI, you sort it out there. But there was no problem between us. It is just that an article on ancient Indian maths, he could not take it. Now, now I am coming to more serious things. So, I have written on this topic. I have been giving lectures since 2014, and that time Avinash Sathe was visiting ISI, and independently he had the same interpretations as I had. So, we had these discussions. After that, both of us have been lecturing on this, and for the first time I wrote it in paper form was in the Bhavna issue of July 2023, that 0 divided numbers in Indian maths. So, this will contain part of this will contain whatever I will be saying today and much more, because Bhaskaracharya will be discussed at length, which I will not touch upon. Now, what happened is that this article was sent to, Arvinda had also sent the article to, Arvinda means C.S. Arvinda, who is the editor of Bhavna. So, he had sought his permission to use one of his statements in the previous issue. So, out of courtesy, he also sent him this article. And after reading this article, Mumford wrote me, I did not send him, it was Arvinda who sent it, but Mumford wrote a personal mail to him, and you can see that what reaction triggered by him, triggered by this 0 by 0. So, he says, dear Amartya, Arvinda was kind enough to draw my attention to your recent article in Bhavna on 0 division. It is an interesting survey, but it made me realize that algebraic geometry has something more to add with respect to the mysterious 0 by 0. So, that is the concept of blowing up points on algebraic surfaces. Adding infinity, this is something which all our authors, this adding this infinity starting from Kaplan to everybody has been mocking at. And what Mumford is saying, this adding infinity makes reasonable sense as having the value infinity for x by 0 if x not equal to 0. But what algebraic geometry does to resolve 0 by 0 is to replace the point 0 by 0 in the xy plane by an entire projective line, allowing 0 by 0 to take on any value, even infinity. So, as I told you that Bhaskaracharya, Brahmagupta keeps it down to 0 by 0 is 0, whereas Bhaskaracharya keeps that flexible. He does not say 0 by 0 is 0. So, all these things I had discussed, and so he says that 0 by 0 in the by replacing it by the entire projective line, it can take on any value, even infinity. It does this by introducing two affine charts with coordinate x by y and y by x as coordinates. Thus, 0 by 0 is defined as an entire projective line. On a personal note, I fell in love with algebraic geometry when I learned of this construction. Best regards, David. So, just see the two extremes. So, and you can see this reaction. He is not saying that Brahmagupta is great or Bhaskaracharya is great. You see, the mathematician starts getting nostalgic about this 0 by 0 thing. So, that is why this statement of Vivekananda that it requires another Vivekananda. Had there been another Vivekananda, he would have understood what this Vivekananda has done. This I mean, when I read about it, this keeps on recurring, that unless there is somebody like David Mumford, it is very difficult to do justice to someone like Brahmagupta. Now we come to, so now this Mumford, whatever is saying, this is too esoteric. So now let us come to more down to earth thing regarding the discussions about division by 0. So to this to get into Brahmagupta, we have to, I mean, Brahmagupta or Bhaskaracharya, their attitude to 0, to division by 0, we have to first of all distinguish between the algebra approach and calculus approach. So I will give some examples which has nothing to do with division by 0, that how we may need to unlearn certain things in order to get into something different, some different approach. So first, an expression which may not be valid in the framework of basic calculus may be valid in a framework of sophisticated algebra. So I will give two examples. Is this valid? 1 plus 2 plus 2 square plus dot dot equal to minus 1. So people whose knowledge is restricted to high school level, they will just think that this is the formula for GP series, that a plus AR plus AR square plus dot dot, that is A by 1 minus R, but that you can apply when mod R is less than 1, and so somebody has applied that result without taking care of the restriction. This will be the attitude, and he will be anybody who writes this will be thought of very poorly, but this is actually a valid result. So in calculus it is absurd, but in algebra it is correct. In the two-adic completion of the ring Z, in the ring of integers, this is what is written. I mean, that expression in the two-adic expression, this is a valid expression. Next, I will take this. Is the following expression valid? 1 plus x square plus dot dot plus x to the power n plus dot equal to 1 by 1 minus x. So the calculus answer is that it is conditional only if minus 1 less than x less than 1. But in algebra it is unconditional. It is a valid identity in the ring of formal power series R x. In fact, if you are in that groove, that formal power series, the phrase minus 1 less than x less than 1 is meaningless, because x is an indeterminate. Okay. So there is no question of comparing it with it is algebraically independent over the real lines. So this is just meaningless. Minus 1 less than x less than 1 is meaningless. The first expression is meaningful. So you cannot read anything out of context. That is the lesson we should learn from modern mathematics. And since this lecture is being held in Bhaskaracharya Pratishthana, you cannot omit a reference to its founder, because it cannot be bettered. So he has this famous paper, Historical Ramblings in Algebraic Geometry, where he talks about the history of this power series. Generally speaking, from Newton to Cauchy, mathematicians used power series without regard to convergence. So what he is talking about is that this R power series x. So this is a ring. So concept of ring comes only in the 19th century. But Newton, being a great mathematician, he was working in the power series even before power series was defined. But then later mathematicians, they were criticized for this, and the matter was rectified by the analysts Cauchy and Abel, who developed a rigorous theory of convergence. So people like Abel and Cauchy, they thought that Newton, when he was working with arbitrary power series, he was not doing correct mathematics. So generation after generation. So first Newton and Cauchy, then first Newton, then Cauchy and Abel. After another 100 years or so, we were taught, say by Hensel, Krull. So, after 100 years, what is the time? That is the late 19th century. So, when people like Hensel, Krull is of course 20th, Krull and Chevalier are coming in the 20th, early 20th, first half of 20th, and Hensel is in the second half of 19th. So, after another 100 years or so, we were taught by Hensel, Krull and Chevalier that it really did not matter. We may disregard convergence after all in the power series. So, the algebraist was freed from the shackles of analysis, or rather as in Vedanta philosophy, he was told, algebraist was told that he always was free, but had only forgotten it temporarily during the reign of Cauchy and Abel. So, this is an expression, this is a passage which one has to memorize by heart in order to understand Brahmagupta Bhaskara treatment of 0. So, now let us take up this division by 0 in ancient India. Was it an error? So, division by 0 is declared undefined in current mathematics. Nothing wrong with that, but there is a difference between undefined and meaningless. So, undefined is that we are saying it undefined, but somebody else could define it. So, is it not just a convention? It is a safe and convenient convention, but it is still a convention. Why this convention has been made? Because there are some difficulties. If division by 0 is admitted, but you can address those difficulties. Anyway, that the notion is undefined has led to a deep rooted belief that division by 0 or fraction with 0 denominator is impossible. So, undefined has been equated with impossible, and then people think that those who had like when ancient Indians did that, they did not realize that it is impossible. And it is not in the domain of mathematicians, it is gone into the popular level, public perception so much, the perceived impossibility is even a theme for Rajnikant jokes. If you look at the list of Rajnikant jokes, that Rajnikant can answer a missed call, then Rajnikant can travel faster than electricity, and etcetera, etcetera. So, in that list, I saw two things about mathematics. One is that he counted from 1 to infinity twice. Okay. But the other is Rajnikant can divide by 0. So, just you see the impact that I mean people who would like to make jokes about this Rajnikant, they are talking about Rajnikant can divide by 0. So, it is so pervasive it is about the impossibility of 0. So, we do not all this is because we do not usually dare to conceive of any mathematical framework with a different convention permitting fractions with 0 in the denominator. Now, let us consider straight away this Kaplan's argument, and which is repeated by various people, and even earlier such arguments have been given. So, if m by 0 is infinity equal to n by 0 with m not equal to n, then cross multiplication gives m equal to 0 into infinity equal to n, and that is a contradiction. So, any mathematician should be asking these questions. What if m by 0 and n by 0 are considered unequal when m not equal to n? So, this is one flaw with the argument. Second is, what if cross multiplication is not permitted for such 0 divided numbers? So, can one not have a valid number system with possibly new numbers? Let us call x by 0 as y, with suitable restriction on the operation 0 cross y, for instance by treating 0 cross infinity as undefined, or with restrictions on the validity of cross multiplication. That is, can we not permit or can we not introduce new numbers x by 0, but without the implication x by 0 is y implies x is 0 times y. So, in fact, the stupidity of this argument, m by 0 is infinity equal to n by 0, then by cross multiplication m equal to 0 into infinity equal to n. By such argument by contradiction, we may also claim that we cannot multiply by 0. Since m into 0 equal to n into 0 would imply by cancelling 0 that m equal to n. So, why we are allowed to multiply by 0? M cross 0 is 0. Why you do not have problem with that? Because m cross 0 is n cross 0, therefore, m equal to n. Now, how we avoid that? We avoid this by making the rule that cancellation principle will not be applied in the case x equal to 0. So, in mathematics, one of the central themes is, I mean that is why my student has become so famous, that she showed that for affine spaces cancellation cannot be done if for spaces from 3 onwards, 3 dimension onwards, cancellation cannot be done in positive characteristic. So, it is the issue whether you can do cancellation under. So, we have this rule that we will do cancellation, but not if x equal to 0. So, what prevents us from making such a restriction for cross multiplication 2? In fact, to give this to drive home this point, let us just set infinity to be 1 by 0. Then the relation m by 0 equal to n by 0 takes the form m infinity equal to n infinity. And if we make the rule that the cancellation principle m cross x equal to n cross x implies m equal to n will not be applied in the case x equal to infinity, just as it was forbidden in the case x equal to 0, then where is any contradiction? So, just as you do not apply cancellation for x equal to 0, you also do not apply cancellation for this 1 by 0. So,
Bhaskaracharya takes m by 0 and n by 0 as different numbers.
yes, yes. So, I am not going, but I am just raising this question. I am just saying that how those who are laughing at it, how their argument is flawed. Brahmagupta somehow does not elaborate on these numbers m by 0, which Bhaskaracharya has done. So, as I said that is a very long story what Bhaskaracharya has done. So, an analogous situation from the past. There was a time when square roots of negative numbers were considered non-existent and forbidden. Even the validity of subtracting a bigger number from a smaller number, that is existence of negative numbers, took a long time to gain universal acceptance. Now, this argument by contradiction that can be so slippery, you can see this, an argument by contradiction to show that root minus 1 does not exist. So, the rule root a into root b equal to root a b would yield that minus 1 is root minus 1 into root minus 1, but root minus 1 is root minus 1 into root minus 1 by using the rule root a into root b is root 1 and root 1 is 1. So, there is a contradiction. But now root minus 1, once you realize that root minus 1 is once you are forced to accept it, then what is done is you put suitable restrictions on the use of the rule root a into root b is root a b. So, can we not conceive of fractions x by 0 with suitable restrictions? Now, the point is that in some areas of modern mathematics, versions of x by 0 are indeed introduced with suitable euphemisms. So, I will give you some examples. Look at the subject commutative algebra, and there is a concept ring of fractions. So, for any multiplicatively closed set S, that means multiplicatively closed set S means that if A and B belongs to S, then A times B belongs to S. For any multiplicatively closed set X of a commutative ring R, one constructs a new ring called S inverse R, where elements of S become invertible by introducing fractions of the form A by B, where A belongs to R and B belongs to S. And two fractions are defined to be equal if they satisfy certain equivalence condition. We are not getting into this. Now, the point is there is no restriction on S. S is allowed to include 0. Take any book in commutative algebra. In fact, yesterday I delivered a memorial lecture of N.S. Gopalakrishnan, and he has this excellent book on commutative algebra. You can see that S includes 0. So, if 0 belongs to S, then all elements in the extended ring become the 0 element of S inverse R equal to 0. So, in particular, if you take 0 from R and 0 from S, then what happens to 0 by 0? It becomes 0. So, in commutative algebra, we do use 0 by 0 is 0. In fact, A by 0 is equal to 0 in this case, even when A is a non-zero element of R. But the point I am trying to say is, here is an instance of rigorous, formal, mainstream modern mathematics, which permits fractions with 0 in denominator and accommodates expressions like 0 by 0 equal to 0. So, one should come out of that cultural shock on seeing Brahmagupta's thing. Now, one thing you may feel uncomfortable is that when 0 belongs to S, the ring S inverse R does not have a rich structure. It is literally a trivial ring. But now, I will give another example in modern theory of abstract integration. A close analog of Brahmagupta's rule 0 by 0 equal to 0 is used in a more substantial way. So, now what I will do is that one of the most respected expositions on the modern theory of abstract integration is a book by Rudin. So, in the Rudin book, Real and Complex Analysis, I will just quote from there. Now, setting infinity equal to 1 by 0 to see the correspondence with Brahmagupta's rule. So, setting infinity equal to 1 by 0, the rule 0 by 0 of Brahmagupta may be envisaged as 0 into infinity equal to 0. And this is precisely the modern convention adopted in measure theory and probability theory. And you know that gentleman who copied from this internet article and wrote an article in Resonance, he is actually in this area, measure theory and probability. He would have gone through this Rudin. But when it comes to this ancient Indian mathematics, they lose their, they shut off their mathematical soul while reading about, while discussing ancient Indian maths, and bring out their political soul. That is the problem. So, let us define, so what is written in Rudin. Let us define A plus infinity equal to infinity plus A equal to infinity. That is precisely the rule that will be given by Bhaskaracharya, by the way. A into infinity equal to infinity into A equal to infinity, and 0 into infinity equal to infinity into 0 equal to 0. This is printed in Rudin. So, which basically means 0 by 0 is 0, and that is what people are using in measure theory and probability. So, sum and product of real numbers are of course defined in the usual way. Now, what Mumford had talked about when he regarding this Brahmagupta 0 by 0, the only oddity, he used the phrase oddity. Same thing, it may seem strange. Strange is another word for oddity, that to define 0 into infinity equal to 0. Now, whatever I was saying, just see all these things is printed in Rudin. However, one verifies without difficulty that with this definition, commutative, associative and distributive laws hold in the extended real line 0 infinity without any restriction. The cancellation laws have to be treated with some care. A plus B equal to A plus C implies B equal to C only when A is finite, A is less than infinity, and AB equal to AC implies B equal to C only when 0 less than A, that is universally known, and he imposes A less than infinity. So, it is already there. Or you look at valuation theory.
Domain when A is not 0, then cancellation holds.
So, convention in valuation theory. So, let K be a field and you look at K union infinity. So, this is all copied from Bourbaki's commutative algebra book, and you know Bourbaki is considered a legend in terms of mathematical precision. In fact, he is so fastidious that Bourbaki is also used as a term of abuse, that if somebody is too meticulous, too fastidious, is called Bourbaki. So, it is at that extreme. So, in that such a fastidious group of authors called Bourbaki. They are writing the laws of composition extend to K union infinity by setting A plus infinity is infinity, etc., and then extend similarly to K tilde by setting, just look at the last line, that 1 by 0 is infinity and infinity 1 by infinity is 0. So, this thing is printed 1 by 0 to the power minus 1 is 1 by 0, 1 by 0 is infinity, that is printed in an algebra book. So, the point is that what is common to the Rudin's book, book is not Rudin's principles of mathematical analysis, it is real and complex analysis where the approach is different, it's coming from an axiomatic approach, this abstract theory of integration, it is not that calculus kind of integration. So, there you have this kind of strange things, and here in valuation theory, that is pure algebra, no analysis. And so, there it is printed 0, 1 by 0 is infinity. So, now we come to division by 0 in Indian mathematics once more. So, it is not that either Brahmagupta or Bhaskaracharya was developing the theory of valuation or theory of abstract integration. So, I am quoting all these things to just show you that whatever they have adopted, they are considered as valid conventions in some branches of modern mathematics. But the question is that why did they do that? Because when mathematicians use 1 by 0 is infinity in valuation theory, they have a certain purpose, these measure theorists have some purpose. But why they did that, that will not be known, because ancient authors do not fully elaborate their thoughts. In particular, the full elaboration of their thinking on division by 0 is not to be expected, but rather to be inferred. Like we deduce from numerical examples of Babylonian knowledge of quadratic equations that that they knew the method of completing the square, or Diophantus's awareness of the identity on sum of two squares. He never wrote the formula because he didn't have algebra actually, but his from the numerical examples that he has given, we inferred that he knew the that identity a square plus b square into c square plus d square can be written as sum of two squares. He has not written such a formula, but he has given examples, and that example suggests that he knew it. So, we have to similarly infer. And why did they do that? Because the texts present only the outlines of any theory, details were transmitted orally and partially recorded in the commentaries. And the justification for this ironically is given by Bhaskaracharya, because Bhaskaracharya is somewhat an exception in the Indian tradition, that he is one of the most lucid expositors, okay, not like Aryabhata or Brahmagupta. But that Bhaskaracharya, who is the master of lucidity, he says, what is the necessity of details for the intelligent student? A mild instruction suffices, for it helps the intelligent student to develop the knowledge on his own. And this is also the attitude, the dominant view among mathematicians of our time, that one shouldn't give out the full details. Now, certain points should be noted here, that we have adopted the convention because basic 4 fundamental operations, addition, subtraction, multiplication, division, these are meant for common people. Okay, this is not only for the Bourbakis or Rudins. And division by 0, since there is a certain problem with it, therefore, it is safe to declare it undefined rather than people making a mess of it. Now, that is something which was recognized in ancient India. So, the problems which people are talking about, it is not that ancient Indians were unaware of it, because division by 0 is also forbidden in ancient India in the arithmetic books, because arithmetic books are for the masses and algebra is for the esoterics, I mean for special class of people. It is only there that it is permitted. And this is something which is written clearly by Narayana Pandit in the book on arithmetic. So, he has this when he is writing on arithmetic, Patiganita. Here in Patiganita, division by 0 is not recognized. Contrast it with what our generous mathematicians are saying, that they did not attain the maturity to realize that division by 0 is not possible. They of course knew that there is a problem, and therefore, division by 0 is not recognized in arithmetic, and therefore, it is not mentioned here. So, in the arithmetic book, he says we will not talk about division by 0 because it is not recognized in arithmetic. As it is of use in Bijganita, as it is of use in algebra, so I have mentioned division by 0 in my Bijganita. Now, this is a very mysterious statement, that what was their use of division by 0 in Bijganita, that is something that now unless somebody comes up with a manuscript which has not yet been deciphered, where some substantial application has been made, we have to just remain content with it. But that it is very significant that Narayan Pandit says, as it is of use in Bijganita, so I have mentioned division by 0 in my Bijganita. So, they had probably some substantial applications of division by 0. As you can see that our modern mathematicians are making substantial use of division by 0 by appropriate notation. So, modern historians try to interpret ancient Indian verses on.
Book on Bijganita available?
Yes.
So what does he say? What does he say in his book?
No, in Bijganita you do not see the see in Bijganita he has defined division by 0. So, he says I have talked about division by 0 in Bijganita. Bhaskaracharya gives, but the point is that whether they had any kind of more sophisticated thinking which they have not noted down in the books. So, they might have some kind of theory which was probably not as crystallized for writing into books.
Narayan is saying in his Bijganita about division by 0.
No, he is including division by 0, that is it. Like Bhaskaracharya, Bhaskaracharya has used division, not used, but Bhaskaracharya has defined division by 0 and operations with divisions by 0. But I am saying that applications, making applications of that, that is not there in Bhaskaracharya or any of his commentaries. But this is significant that Narayan says as it is of use in Bijganita. Why he said that, now we have no clue. So, modern historians try to interpret ancient Indian verses on division by 0 in the light of calculus. And because they interpret them in the light of calculus, some of the verses appear imperfect, flawed expressions of calculus principles. This applies more to Bhaskaracharya, not Brahmagupta. Some of the verses appear imperfect, flawed expressions of calculus principles, some appear as absurd errors. Some of the examples of Bhaskaracharya appear as absurd errors. The picture changes in the light of algebra. Now, why algebra interpretation that Sate had given and independently had thought about it, and later we discovered that those interpretations are already given by commentators like Ganesha and Krishna. So, the algebraic interpretation is appropriate as it is usually in the sections on algebra that rules on division by 0 occurred. So, Brahmagupta has two chapters. One is Ganitadhyaya and another is Kutakadhyaya. In Ganitadhyaya, he does not get into division by 0, it is only in Kutakadhyaya. Similarly, Bhaskaracharya talks about division by 0 in this thing, Bijganita. In Lilavati also he talks about it, but in Lilavati the approach is somewhat different, which I am coming to it. And as Sate remarks, Avinash Sate remarks about algebra, the first bold adventure into the unknown. Now, rules of division by 0 in a general text like Lilavati. When it comes to Lilavati, the way Bhaskaracharya does it, it can be interpreted in the framework of both algebra and calculus, because Lilavati is meant for applications. So, there thing like what is called Kha Guna, which can be thought of as an epsilon. This epsilon can be thought of as an idempotent, or it can be thought of also as some quantity which goes to 0. It is ambiguous. Whereas in Bijganita, you should not be taking it as epsilon which goes to 0, because it is an idempotent. And the fact that idempotent was my and Sate's independent interpretation, but later we realized that we did not have to make any interpretation. It is very clearly said in Ganesh, in Krishna. And later we found that in Bhaskaracharya's own commentary also, he has made it clear that these are idempotents. Oh, I think this is the so much for this division by 0, but there is a lot more to be said in the context of Bhaskaracharya's verses. So,